Hello, this is that. Today we'll now be doing question 2 of 2014. So what now? We have a cubic equation. So if we rearrange and substitute, we get 1 plus 2b minus a squared minus b squared equals to 0. So this rearranges to a squared plus b minus 1 squared equals to 2. As a squared is greater than or equal to 0, then b minus 1 squared is less than or equal to 2. And if we solve this, b squared minus 2b plus 1 is greater than or less than or equal to 2. b squared minus 2b minus 1 is less than or equal to 0. Now, as you can see, this constant term can make all the difference between a repeated root and two irrational roots. In the two irrational roots, which we're asking for, 1 minus square root of 2 and 1 plus square root of 2. Since it's less than 0 and this coefficient is positive, we can just as easily write this. There, we're done. Show that there is no value of b for which x is 1 is a repeated root. So this means substituting a squared is 1 plus 2b minus b squared. We already figured that out. And get 0 equals to x cubed plus 2bx squared plus b squared minus 2b minus 1x minus b squared equals to, and then we do x minus 1 x squared plus 2b plus 1x plus b squared. And if x, let's substitute x equals to 1 into the second bracket. If x is 1 is a repeated root, then we expect 1 to be roots on this. But can it? 1 plus 2b plus 1 plus b squared must be equal to 0. And then we complete the square, b squared, no, it's b plus 1 squared plus 1 equals to 0, which is impossible for real b. Yay! For the value of b, does this cube have a maximum or minimum at its repeated root? Hold on, I may need to scroll a bit. Oh, technical problems. Why don't we just write it here? So, when x equals to 1 can never be a repeated root, then it can only have a repeated root by the quadratic factor having a repeated root. So this means 2b plus 1 squared, this is the discriminant, minus 4 times 1 times b squared, that's the discriminant. So this means that 1 plus 4b, if we calculate this properly, equals to 0. This obviously equals to 0, and b equals to negative a quarter. When b is negative a quarter, then we will substitute x squared plus 2b plus 1x plus b squared equals to x squared plus x over 2 plus 1 over 16, which is equal to x plus a quarter squared. So the repeated root also negative a quarter. That means there is a local maximum at the repeated root, as it is less than the single root. Then, the knowledge of the cubic shape, we can infer this. Obviously, if b is negative, then the converse will be true, right? So you might want to check out Bostock and Chandler's great book Pure Mathematics, which also has a chapter on, guess what? Cubics. Well, see you in another MAT video and hope you have fun.